This video is going over how to find probabilities using the Poisson distribution. Okay, so say we've got the following question. The Poisson random variable x has standard deviation of 2.67. What is the mean? Okay, so for the Poisson variable, the mean equals the standard deviation squared, or the variance. So just to find the mean, it's as simple as getting that 2.67, that's the standard deviation, and squaring it. So 2.67 squared, and that's the mean, and that's what we need. We always need the mean to find any probabilities using the calculator. Okay, so that was the vital first step. Now, for the next question, it says find the probability that x equals 2. So we press menu, statistics, distributions, scroll down, and now we've got the Poisson PDF and Poisson CDF. We choose PDF if we have x equals a value. So Poisson PDF, this here is the mean, so we put in 7.1289, and then they want the x value, which was 2. Press OK, and that's the probability there, that x equals 2. Okay, the next question. It says that find the probability that x is less than or equal to 3. Okay, so now because it's less than or equal to, we want to use CDF. So we go statistics, distribution, scroll down, Poisson CDF. Okay, so again I just put in the mean, 7.1289. And I wanted it less than or equal to 3, which means the lower bound is 0 and the upper bound is that 3 that we want. Now the Poisson is really just on integers, so it's like 0, 1, 2, 3. So we don't need to worry about decimals and things like that, which is good. So there we go. Press OK, and there's my probability that it's less than or equal to 3. Now for bigger or equal to 5 and less than 7, the next one, we go menu, statistics, distributions, Poisson CDF. Okay, again, same mean. The lower bound now is 5 because it was bigger or equal to 5. The upper bound is actually 6 because it's less than 7, so I don't actually want 7. I want the one below it, which is 6. Press OK, and there's my new probability. Probability that x is bigger or equal to 3, given that x is bigger or equal to 1. Okay, if you remember, the formula for this is it's the intersection of those two events over the second event. So this one, bigger or equal to 1. Okay, now the intersection of x is bigger or equal to 3 and x is bigger or equal to 1, that's actually just x is bigger or equal to 3. Okay, because bigger or equal to 3 satisfies bigger or equal to 1. So we can just take x is bigger or equal to 3. Now how do we find that? Let's do that first. The probability that it's bigger or equal to 3, we need to find its complement. So the complement of something being bigger or equal to 3 is less than or equal to 2, because remember there are no decimals, so we don't want to include 3, so we just go less than or equal to 2. So, and then we find the complement of it. So complementary means we take away from 1, and then we do menu, statistics, distributions, Poisson CDF. We put in the mean again, which is 7.1289. And then the lower bound is 0, and we go up to 2, because that's the complement of bigger or equal to 3. Press OK. And then so, because we've done 1 minus that, then the final probability is the probability that x is bigger or equal to 3. So now we'll do the bottom, which is just bigger or equal to 1. So again, it's bigger or equal to, which means I need to use that complement idea. So it's 1 minus. Now if it's bigger or equal to 1, that means I want less than or equal to 1 minus that, which is 0. So I'll go menu, statistics, distributions. Now I'm going to stick to Poisson CDF. Technically we can do PDF because less than or equal to 0 is actually just 0. But since we're still talking about intervals, we'll just stick with CDF. Put in our mean, lower bound is 0, upper bound is also 0. Press OK. And there's my denominator. So this, down here, what I've just found is the probability if x is bigger or equal to 1. Okay, so now basically I want to put that on top of that. So if I go up, it's this divided by, up again, this. Now, I'm not convinced that's going to work properly, so I might put in some brackets, just to make sure it's all of the numerator divided by all of the denominator. Yep, let's put the bracket in already, press enter, and there's your final probability.